Hey, seventh grade, good morning. It is Mr. Connolly here. So what I'm going to be doing today is kind of just talking about a couple of things that we've been discussing lately, especially the week before spring break. Speaking of, I hope you guys had a healthy and happy and enjoyable spring break, and I hope that you're all doing well. I know things are really weird right now, and far from the normal daily life that we're used to. But I'm really looking forward to seeing you guys again. But for right now, the best that we can do is kind of just interact through these videos. I look at your surveys, and if you guys would be interested, I think it would be kind of fun if we could try doing a Google Meet, just to, not like a mandatory thing. Like, you don't have to. It could be like just like a 5-10 minute check-in with me and Mrs. Shamble, just to, if you guys want to join in and say hi, talk about what you've been doing to stay busy, and just you maybe talk about your spring break, or if you have anything on your mind you want to talk about school or science or whatever. I do think that would be kind of a fun little thing that we could all do as a class. All right. So before spring break happened, we were talking about weathering. We were talking about two main types of weathering: mechanical weathering, in which the rocks and the sediment is broken down physically, as if you were taking a hammer to a rock for thousands of years. Eventually, it would start to crack. All right, we're talked about also chemical weathering. So we're talking about the process that breaks down rock through chemical changes rather than physical changes. Okay, so we're also talking about erosion. All right, erosion is the removal of sediment from one place to another. All right, and then we're also talking about, okay, well, what happens when the forces of water or the forces of wind or the forces of ice, all right, what happens when those forces, all right, starts to diminish, or they start to become less in strength and less magnitude? Where does the sediment go? All right, so once erosion's done and that sediment, once that sediment is carried somewhere else, all right, then it redeposits in another location. All right, that's called deposition. So deposition occurs where the agents of erosion, all right, deposit, or they're starting to lay down that sediment that was carried by that erosion. So eventually that sediment is going to be carried away through erosion, and then as the agents of erosion stop, it's going to lay that sediment back down in another location, right? It's depositing it somewhere else. That's called deposition. So for example, all right, so if I have some different types of like sediment and rocks and boulders up here, all right, due to the axial tilt of this slope, all right, we have the agents of erosion being caused by gravity. All right, gravity, all right, just like if you jump up and down, all right, if you jump up, you don't fly away forever. Gravity is going to be like, hey, hold up, and it's going to drag you back down. All right, so we have these rocks and different types of particles and different sizes of sediment, all right, being pulled down, all right, due to the causes of gravity. All right, it was up here, erosion removes it and places it somewhere else. Right, this is deposition. So all of these little boulders and rocks and different types of minerals and sediment sizes, they were once up on this slope, or maybe they were brought in by this river. All right, but this is where it got newly deposited. So these rocks haven't always been here. The agents of erosion have brought them here. All right, and then the agents of erosion stopped and deposited the sediment somewhere else. Right, that's deposition. It's redepositing it somewhere else. Okay, so weathering, erosion, and deposition go hand in hand. All right, they don't work without the other one kind of pitching in and doing the job with it too. So we have weathering, which is going to break down the rocks. All right, erosion, once those rock sediments and those different types of particles become small enough, or they can be carried away, all right, through erosion, all right, eventually erosion is going to stop working, all right, under the influences of gravity, or maybe wind stops blowing, or maybe at the end of the river it stops flowing. All right, once erosion stops, it's going to redeposit those sediments somewhere else. So weathering has to take place in order to get the sediment size small enough to be picked up by erosion. All right, and eventually the agents of erosion are going to stop working. All right, or it's going to redeposit those sediments somewhere else. All right, and that's deposition. So each one goes hand in hand. They all work together to kind of form these mountains and form these big landscapes. All right, and then it breaks it back down and carries it somewhere else. All right, so you can't have one without the other. It's like they work as a moving part. Okay, so when we're talking about mass movement, all right, we're talking about the main influence of gravity. All right, so gravity, as you know, and you should know, is the force that moves rocks or other materials downhill and causes a mass movement. So mass movement is just the material of these rocks and these particles and the sediment sizes going from one location to another down a slope or downhill, all right, due to the influence of gravity pulling it downward. All right. So when we talk about mass movement, we're really talking about the four main types. The one that I'm sure you've all heard about before, all right, are landslides. All right, these are very, very deadly. These are very sudden. All right, and is something that's caused mostly by triggering of earthquakes. All right, mudflows. These are a little unique in the fact I think you've heard of these before, but mudflows can be very, very still or very, very slow moving active, or well, I'm going to show you a quick video. Some mud flows can be very catastrophic and very, very fast moving down a slope. It really depends on the angle of the slope. So if the slope is very, very steep, obviously that sediment gravity is going to work a lot faster. It's going to bring those sediment particles down a lot quicker. But if you're on a very narrow or a very gentle slope, all right, it's going to start to flow due to the different clay minerals and the different clay soils. And after a heavy rainfall, we're going to learn about, it's going to bring it down very, very slowly. So all has to do with the angle of the slope. Is it very narrow? Is it very steep? Right? That's really what's going to determine whether or not it's catastrophic or really, really harmful or deadly, or if it's just a gentle moving of mud down a slope or downhill. All right. The third and fourth one, I'm not really sure if you've heard about before, but we're going to learn about a little bit, is slump. All right. And then we're going to learn about creep. Okay, so these are the four main types of mass movements. Remember, mass movement is just any one of these several processes, 1, 2, 3, 4, landslides, mud flows, slump, and creep, that move the sediment involved in these types downhill or down a slope, all right, due to the main influence of gravity. Okay, so when we talk about landslides, all right, landslides are definitely the most destructive. There's a large amount of soil and rock just suddenly fall down a slope, so it's a very sudden movement. And it occurs when rocks or soil slide down a very steep slope. And a majority of the time, landslides will occur because of the influence of earthquakes. So earthquakes, when they start to rumble and they start to trigger those seismic waves, all right, it's going to start to loosen up the soil. It's going to start to loosen up the dirt and all the different rock types. And if they get too loose on a really steep slope, there's nowhere left for those loose particles to go except for downward. Okay, so when earthquakes trigger the rocks and the bedrock underneath the soil to loosen up, it's going to allow gravity to start doing its thing, and it's going to pull all those rocks downward really, really quickly and really catastrophically. All right, one of the most catastrophic landslides that's occurred was in El Salvador in Central America in 2001. All right, you can see on this slope right here, all right, on this downhill gradient, all right, all of these rocks that are now here, all right, this is a deposition, so erosion moves it down and deposits it somewhere else, all right, but weathering, right, the use of earthquakes is what loosened up those particles, loosened up all that soil, loosened up all those rocks, and it eventually, gravity did its thing, and it dragged all of these, right, larger pieces of sediment downward down the slope very, very suddenly. So this was a very, very quick occurring landslide, very catastrophic. Estimated about almost 580 people were harmed or were killed due to this mass movement of rock and soil and rocks and different sediment sizes. So it's a very sudden, quick downhill movement of rock and soil. All right, and then you have your mud flows. So mud flows are a rapid downhill movement of a mixture of rock, soil, and water. And mud flows normally occur in areas that are normally dry, but then they have heavy rains, very sporadic. So it's like areas kind of like in the desert. So in the desert, there's not a lot of days throughout the year where you're going to get a lot of rainfall. So it really makes the soil and the rock underneath the those areas be very, very dry. But if you get a sporadic or very quick, rare occurrence where there's heavy and a lot of rain falling, you have these soils and these rock types, especially like clays, that are normally very, very dry due to the climate of those regions. But now, all right, so since there's so much amount of heavy rain coming in these areas, it makes these clay soils very, very wet. And clay soils, which some of you may know, is very, very slippery. All right, so when it happens, it's very, very slippery, and you have these soils being loosened up, and now they have this fluidity. All right, they become a fluid. All right, it becomes a really muddy mixture of this rock and the soil and this mud that starts to travel down slope. So if the slope is very, very, very steep, all right, this mud flow can be very, very catastrophic. It can be very, very dangerous. And this is a really great video of something that's kind of like talking about this. Hold on. Massive mud flows. Okay, so this is taken in Switzerland, all right? And you can see the high mountains at the right. You're gonna see this little rift valley right here, and you're gonna see what happens as mud starts to flow down. All right, so since it is an area where this the gradient of the slope or the downhill movement of this mountain is very, very steep, this mud is going to flow down very, 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 very quickly. So this is more of a catastrophic, more deadly mud flow. But thankfully, a lot of people in the area were asked to evacuate, and this also was triggered due to a sudden heavy rainfall the night before. And you can really start to see the pileup of all the sediment. So now that the agents of erosion, it's on a steady slope, gravity stops, moving the particles downhill, and it deposits it somewhere else. So this is a good example of deposition. It was up on the top of this mountain, gravity brought it down through the agents of erosion, and now it deposits somewhere else, right? So this would be a really good example of a mudflow or a mudslide, okay? So moving on, all right, there's two other types. There's a slump and then there's a creep, all right? So not a creep, but creep, all right? That's something else. Slump is a massive rock and soil that just suddenly slips down a slope as one whole. So in a landslide, it can all kind of crumble down in different waves. So like one particle can fall down due to it being loosened up, and then gravity brings it downward, and then those sediments and those rocks and those big boulders can run into other boulders, triggering that to fall as well. So it kind of all comes down like a domino effect. You have one domino knocking down the second domino, down the third, the fourth, the fifth, all the way down until there's no more dominoes left. Right? That's a landslide. It's a very sudden movement, and one thing triggers another thing to move, right, down that slope. In slump, everything just falls as one. Okay, so it's as if the entire landscape literally just collapses underneath it, kind of like a sinkhole. All right, and normally how this will occur is in a slump. It may be caused by a layer of slippery, wet clay or slippery, wet soil. So maybe the rain penetrated through this layer right here. All right, and because these layers are sitting on top of it, it all just kind of slips and slides underneath it. All right, so this is a sudden movement of soil and rock and clay, soil, rock, and different sediment types, but it all kind of comes down as one. All right, versus a landslide is kind of like a domino effect. All right, it all comes down at different time frames. Okay, and then creep is the very slow movement of rock and soil. All right, this often results in the freezing and thawing of water. So I know in mechanical weathering we did talk about ice wedging, or you'll sometimes hear me refer to it as freeze thaw, or freezing and thawing. And this is based on the lower levels of soil and rock underneath the maybe not as cold layers of rock and soil above it. So creep is very, 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 very slow. You only really see the causes or the effects of creep after a couple of years at a time, and some good indications or some really indicators that creep is happening within an area, we call it soil creep, is when you see these like ridges, kind of looks like waves along the soil, which is a very weird pattern unless soil creep is one of the major agents of this region. Another thing you'll see are these tilted fences, right? Or you'll start to see these like wave-like features that you'd see in the soil on the road and the concrete, or a really good indication are these curved tree trunks. So what soil does, and soil creep, or creep in general, it's going to move throughout these freezing and thawing. As water freezes, it expands. So when it expands, it brings these looser pieces of sediment and rocks upward because it's expanding out. And then eventually it's going to, during the day, get a lot warmer, and it's going to resettle. Up and then resettle, up and resettle. So it's moving the soil and it's moving the rocks sporadically throughout the year, really, really slow rates. All right. So eventually, as the soil is being creeped downward very slowly, the things such as the plants and the vegetation, such as trees, they were deposited here, and now they're being forced to curve upward because the land is slowly creeping down. All right. So here's like those creeping soils. So here you had soil creep, starts to go down, starts to go down, starts to go down very, very slowly, a couple centimeters per year. All right, and you start to get these wave-like features, right? The soil in the landscape is literally being folded and being pushed downward so slowly. Okay, so that is soil creep. Those are the four types of mass movement. So we have landslides, mudflows, we have slump, and we have creep. All right, I hope you guys found this video helpful, and tomorrow we're going to be going a little bit more over these mass movements.